Hello, good morning everyone. Today, inshallah, we will continue on reviewing our course. And this is the final version for our course for this semester, inshallah. Of course, as you know, all our course notes and references, you will find it both on Canvas and on our YouTube channel. So on the playlist, so you can follow up with all the events related to our lectures for this course. I will start this revision by going through our courseworks 1 and coursework 2, which cover most of our course or module items. And the final exam for your final exam should supposed to cover for the following learning outcomes. The first one is the knowledge and understanding of Fourier series, and as you know, through our course we have taken the Fourier series expansion in details for various cases, and we will need that down the road in the how to deal with the partial differential equations, either a wave or heat. So it's really a very important topic. You will find it in the final exam. Exactly the same points as we did go through previously in coursework 1. Knowledge and evaluation of some of the integral transforms. One of the most and famous integral transforms that we are going to cover is the Laplace transform. So you will be asked about the forward transforms, backward transforms, or the inverse transforms of Laplace, and then a direct application on solving an ODE or differential equation using Laplace transform. Although you will find problems on the double and line integrals in your final exam. This is really a very important part. Remember, you will have to know the following. You will have to know how to evaluate double integral or double integration for a certain region, how to change of order, when do you need to change of order, how to use polar coordinates in order to evaluate the area for a certain region, how to get the volume, the mass, or the moment of inertia if it's required from you, either above the x-axis, the y-axis, or if it was required to find about polar coordinates, plus the center of gravity. All of this you will find it in the part of the double integration. Also, you have a lot of problems on line integral and on green theory, and maybe you will have some of these problems at your final exam. Also, understanding and knowledge of the numerical methods used in differential equations, and we have taken modified Euler and Roncotta method. For Euler and Roncotta, which is really very important, we already covered Euler previously, so you will be able to go through it. Please also study Roncotta method, the fourth order Roncotta, which is really very important method in numerical evaluation of differential equations. Last but not least, the part of the partial differentiation, the partial differential equations that we have covered. We have covered the types, the classification of PDEs, the successive integration method, the separation method. So you should study this part. I believe you will be subject to one of the main methods that we actually did go through in the separation of variables. So maybe you will find a problem on this part on your final exam. And of course, statistics and probabilities. We really did go through that with a couple of lectures at the end of our course in the previous weeks. Remark and always remember that our final exam will cover most of our lectures, starting from the first lecture till the end of our course. So please go through them, solve these problems, and you will be in a very good shape. Also remember, you are allowed to have one page double-sided, just only laws, the main laws that you may need. Don't write any problems or anything in it, just only the laws. You have A4 paper, double-sided with you, it's allowed. Please read each question carefully, show your work to receive full credit. For sure, your cell phones should be kept in your bags outside the examination room. This is the final cover for, or this is the cover for the final exam. Write your student ID in here, the level which is 5, subject further engineering mathematics. This is a 70% assessment. You will have mainly about 11 questions, from 10 to 11 questions. You will have the marks on your paper. So I usually like to show you the cover of your exam to feel comfortable. You don't have to be intense or get nervous while you are in your exam. Okay? Now, once more, I will get back to classwork 1. Remember, at this, for the classwork 1, you had a couple of questions which were multiple choice questions dealing mainly about Fourier and Laplace, as the first classwork was mainly devoted to cover the Fourier series and the various parts in Laplace. Also, in the final exam, you may have a couple questions that's either MCQ questions or multiple choice. You can go through them, or some questions he will ask you about if you know the law, if you have a quick transform for a certain function, and so on. Here he is stating that the Fourier series in case of even function can be given by, if you remember, we know that Fourier series for any function, if it was not even or not odd function, it will cover a node, and then you will have the cosine part and the sine term really exist in your expansion. But if you are dealing with even functions, it's going to be with cosine terms. You don't have sine terms, so I believe B is the right choice. For the second question, he is asking you about if you have sine n pi over 2 for the numbers 1, 3, and 5, and so on. So what's the right choice? Is it going to be 0? It's going to be negative 1 to the power of n. It's going to be negative 1 to the power of n plus 1. I believe the right answer will be C. For the third question, he is asking you about the suitable Fourier expansion, giving you a function which is 5 plus sine 5 of x, and he's mainly asking you which one of these expansions would work with this type of a function. If you have a question like this, he's actually asking you about the nature of this function. Is it an even function or an odd function? Since we have 5, which is an even function, plus or minus sine to the power of 5, which is an odd function, so simply this is not an even or an odd function, so you will need to choose the whole expansion. Third problem, actually, or the fourth problem, he's asking you about Laplace transform for the inverse of Laplace transform for a quick question, which is, I will write it here. He's asking you about e to the power of 3, I believe, divided by s minus 2. And if I want to get the inverse of this function, it's really going to be very easy. All I have to remark that e to the power of 3 is just a constant, so you don't do anything with it. I will leave it as it is. So it's going to be e to the power of 3. Once more, remember, I can do that 1 over s, but remember, I've replaced s minus 2 by s. There is a property that it can do this, so I will end up having e power 3, 1 over s. It will get back in the t plan to just only 1. And the part that's responsible about replacing every s by s minus 2, as you know, is e to the power of 2t according to the first shifting. So simply f of t could be written as e to the power of 2t plus 3. And in this case, I believe B is going to be the right choice for this problem. Also, he is asking you to get the Laplace transform for t to the power of 3 for the last question. t power 3 plus 2 sine 5t, which is really very simple. T power 3, it's really very easy to find its transform, which is going to be factorial 3 divided by s to a power of 4, plus you will have 2, then sine 5t, which is going to be simply 5 over s squared plus 25, and this way, this how I believe number 8 is the right choice for this problem. This was question number 1, 5 parts, each one of them was 2 marks, so it was really very simple to answer. And here are the right choices. B, C, the problem number C, for problem number D, E to the power of 2t plus 3, for problem number E, which is 6 over s power 4. The second problem in this exam, and it was given 20 marks in order, if you like to find a complete solution for this problem, I will just go for the sketch, your subject, and maybe you will have a function to get its Fourier expansion in the final exam. It's really very vital to draw the main period of your function, showing the repetition through the period, the main period for this function. He wants you to give a sketch from -9 up to 9 for the function f of x, 3 minus 2 absolute x, and x is varying from 0 and then 3 over 2, and for from 3 over 2 up to 3, it's going to be 2x minus 3. So simply, all I have to do is to try to sketch this function within this interval. It's really a very simple. Step to do. First of all, I will start with the positive part. Okay, I will consider f of x, which is gonna equal to 3 minus 2x. That's y equal 3 minus 2x. And this is just only within the period of x is greater than or equal 0 and less than or equal 3 over 2. Here's the y-axis, and this is the x-axis. I will go from x equal 0 to x to 3 over 2, just making substitution in this straight line equation. Inserting x equal to 0 will develop y equal to 3. If we insert 3 over 2 here instead of x, you will end up having y equal to 0. So this is the graph or the sketch for this part of this function within this period. For the other part, the absolute will mean nothing, I mean the positive direction. So it's simply y equal to 2x minus 3, and for this part it will start from x equal to 3 over 2 and end up at 3. So if we start substituting by 3 over 2, you will end up having the value of y equal 0. Then if we substitute by x equal 3, in this it's going to be 6 minus 3, so you will have y equal 3, and this is the shape of this function. I will have to repeat this function on the right and on the left for this main period. This is the main period, which is 2L equal 3. That's L equal 3 over 2. And the rest is going to be like this. So you will end up having 4.5 here. And I believe here it's going to be 6. Same way like it will go over there like this. And in a similar manner, for the negative side of the x-axis, it will go in a similar manner. So this is negative 3 over 2. You will find here negative 3 minus 4.5, then negative 6, and so on. So once you draw your function, when you give a sketch for your function, you will remark this is an even function, and it's required to find its expansion. That's the sine part will equal to 0, and it is required now to get the expansion that states f of x equal to e0 over 2 plus the sum from n equal 1 up to infinity. for a sub n cosine n by x over L, and this is the main function that's required to be found. You will have to get a node, and then you will have to get a n. This is very, very important. So marks will be given for a successful sketch for this function. Also, another grade will be given for the right expansion law that you are going to use, and so on. This is really very important part, and it should be kept in mind. Okay, as I told you, here is the function. This point is at 3, as you know. I've started sketching, so this is an even function, as I told you. It was given 4 marks for the right sketch, 2 marks for writing the suitable law. Then I will start evaluating a node, which is really very simple. If you want me just to make you remember how to write it, it's really very simple. If I want to evaluate a node, so a node simply is going to be 2 over L integrating from 0 up to L, which is the half period. For the function, I will choose the function within the first part, which is simply 3 minus 2x with respect to x. And so, replacing the L by 3 over 2, if we replace L by 3 over 2 here and there, so you will have 4 over 3 integrating from 0 up to 1.5 for a 3x minus, for 3 minus 2x, I'm sorry, with respect to x. Simply, it's going to be 4 over 3, as you know. Open a bracket, it's going to be 3x minus x squared, and then start substituting by 1.5 and 0, and you will end up having 3, so the value of a node will equal to 3. Similar manner for, just a second, let me write it here. Similar manner for a node, if you remember a node, it's going to be really very simple. All I have to do is write an, which is going to equal to same integration, 4 over 3, starting from 0 up to 1.5, for the same function as you know, 3 minus 2x. But instead of evaluating for 3 minus 2x, I will have to add the term which is cosine n pi x divided by 1.5 or 3 over 2 with respect to x, and of course an integration by parts. 3 minus 2x will be differentiated, while cosine nbx will be integrated. The PDF already I've sent it for the standard terms in order to distribute it on all of you. As you see, it's really very simple. Steps are direct, and I've dedicated 6 marks for the successful evaluation of an. Please be careful once you start integrating by parts, then substituting instead of x. Please remember cosine n pi equal negative 1 to the power of n, sine n pi over 2, negative 1 to the power of n plus 1, blah blah blah. You will find all of this and the details related to Fourier series in the lectures that's dedicated for Fourier part. So I would recommend for myself that you go through it and then please try to solve one of these problems till the end of it and start to write your expansion correctly. This way you will be able, you should be able to cover this part successfully. For the third question, and also with 20 marks, you have been given 4 of the forward Laplace transforms, and it's required to find its Laplace transforms, and it's really very simple. The first of them is 5 plus sine 5 of t, which is simply going to be 5 over s plus 10 over s squared plus 25. The second will be 3 over s minus 4. The third one, you have the first shifting. So first of all, I will have to get the Laplace transform for the sine 5t, which is going to be 5 over s squared plus 25. Then I will replace every s by s plus 3. For this function, which is t minus 2 times u of t, this is a second shifting problem. All I have to do is to forget completely that I have u of t minus 2. Let's do it quickly. It's very, very simple. All I have to do, just forget about this part. Why? Because I know this part is responsible about the appearance of an exponential function in the s domain, which is going to be e power negative 2s. Second step, I will replace t minus 2 by just simply t and get its transform, which is 1 over s squared, and this way you will get your fs. As I told you, for 3e to the power of 4t, it's really very simple. All I have to do, if I want to get the forward transform, is simply write 3 over s as the first step, then replacing every s by s minus 4, so you will end up having 3 divided by s minus 4. For this problem, f of s, simply it's going to be 5 over s plus a 5, plus, as I told you, plus 5 divided by s squared plus 25. If we are dealing with this function, which is simply e to the power of negative 3t times sine 5 of t, really very simple to get its transform. He's asking you about the first shifting, which is simply, I'm thinking about 5, but I'm writing s. So it's just simply going to be 5 divided by s squared plus 25, then I will replace every s by s plus 3, so simply you will have, what's more, it seems like my hand like the s letter, so you will have 5 divided by s plus 3 to the power of 2 plus 25, and this is right answer. Here he is asking you to get the inverse of these transforms, which is also very simple. For the first one, it's very, very simple if you try to look at it, which is 6 over s squared minus 16. Let me do this with the next slide. So this is the problem. Those are the main 4 problems that we spoke about briefly, just in a few seconds previously. This is the part that I'm talking to you about, the inverse. So I have 6 over s squared minus 16. Which simply can be both s to the power of 2 minus 4 to the power of 2. I will need 4 on the denominator, so simply I've taken 6 outside, multiplying by 4 and dividing by 4. This part is gonna be sine over 4t times 3 over 4. For this one, the appearance of e to the power of negative pi of s indicates that you will need to have a second shifting. So just get rid of this for the time being. I have s squared plus pi squared. So simply I've multiplied by pi and divided by pi, exactly like this problem. Now this part of this transform, it's going to be sine pi t. But I can't do Laplace transform unless I have t minus pi. So I know this part, which is going to be sine pi of t. Then I will replace t by t minus pi and e power negative pi of s by ut minus p. This is very, very simple. It's just only 5 times e to the power of negative 3t. This is also very, very direct, which is I believe it's t to the power of 2 times e to the power of 2t, as you can see. Here's first shifting theory, and replacing s minus 2 by s, it's gonna lead to t squared. Then I will have to pay the price, as I told you previously in our lectures, that we have to multiply by e to the power of 2t. Here is also another problem. But it will need extra work from you. So he's asking you about how to get the inverse Laplace transform for these functions. Here is asking you about Laplace transform, but it's giving you more than one function that would have an effect on sine of t, and this is the inverse of 3s minus 4 over s squared minus 25. These problems are really very simple and easy to deal with them. If you have any problem related to this part, please go through the lectures dedicated for the inverse Laplace transform, and you will find it, all of them, really very simple, clear, and you will be easy, you will deal with them really very easily. Let's start with our main problem, which states here, get the inverse of ln s plus 1 over s minus 1. As I told you in such problems, first of all, let's put ln of an s plus 1 over s minus 1 on a simpler form, which is gonna be ln of an s plus 1 minus ln of s minus 1. This is the first step. Then I don't have an inverse Laplace transform for these functions, but if I differentiate them, this will lead to this part. It's going to be 1 over s plus 1. For the second part, it's going to be negative 1 divided by s minus 1. So actually, instead of having f of s, at the time being I have f dash s. I will try to put it on the form of differentiating the transform. That's, I will need negative f dash of s. So simply, I will multiply the whole, the two sides by negative 1. So I will have negative f dash of s, which is going to be 1 over s minus 1 minus 1 over s plus 1. Start to get the inverse Laplace transform for these functions. For this part, it's going to be t times f of t. For this one, I can easily get its Laplace transform, which is going to be simply e to the power of t. The other part is going to be negative e to the power of negative t. Then finally, f of t will equal to e power t minus e to the power of negative t over t, as you see. For the second problem, I have 1 over t, which integrate sine t and the e minus t. I know this is the first shifting, so I would say I will go like this. First of all, I will try to get the transform of sine t, which is simply 1 divided by s squared plus 1. Then I will see the effect of e minus t, which is simply states that I will have to replace every s by s plus 1. Then I will have to integrate with respect to the s, starting from s up to infinity. So I'm dealing here with negative 1 divided by s plus 1 to the power of 2 plus 1. I want to integrate, then substitute from s up to infinity. The integration for this part, it's not going to be a logarithmic function or so. This is going to be tan inverse tan of s plus 1 with a negative sign. Then I will start to make my substitution from infinity to s, which is simply, if you start substituting, you will have to tan minus 1 on arctan for s plus 1 minus by over 2 for this function. Of course, the details of these parts, you will find them, I believe, in the third lecture that's covering the Laplace transform. So if you have any problem with these problems, or if it's not clear for you, please review the main lectures. You will find them over there. For 3s minus 4 over s squared minus 25, this is really a very nice problem, and you can solve it using either the heavy side, as I solved it here, or you can simply separate it. One of the nice solutions for this problem is that instead of dealing with f of s, which equal to 3s divided by s squared minus 25, I will let it to be minus 4 over s squared minus 25, and this is gonna lead to, that's f of s can be 3 times s divided by s squared minus 5 to the power of 2, then minus, this is 4 over 5, and for the other part, it's going to be 5 over s squared minus 5 to the power of 2. Simply, it's going to be f of t, which is going to equal to 3 of sine 5t minus 4 over, the first part, this is s, so it's not going to be sine, it's going to be the cosine part, You have to be careful about this. This is sine 5t minus 4 over 5 times sine 5t, and this is for the right answer for this problem. This is a very nice solution. I've separated this part to be a cosine, then sine, then I've succeeded in getting its final transform. Okay? This problem, okay, here is the solution. As I told you, I start to get f of s, then f dash s times minus. I've replaced it, I've completed the integration. Here's the same way, like I've got the Laplace transform for the denominator, taking advantage from 1 over t, which integrate actually the function, then getting the final form. For the part with 3s minus 4 over s squared minus 3, 5, I've chosen to solve it using the heavy side, which is really very simple. All I have to do is to find the zeros of the denominator, which is simply 5 and the negative 5. So f of t is direct, it's going to be a1 e to the power of 5t plus a2 e to the power of negative 5t. The problem is to find a1 and a2. Very, very simple. All I have to do is to erase the zero factor from the denominator, then substituting by s equal to 5, you will end up having 11 over 10 instead of a1. In a similar manner, I got a2. This is the main chain of f of t. Someone may ask himself and say that, well, here's f of t in terms of an exponential function, while the other solution that we already did go through it previously was as a function in cosine 5t and sine 5t. But remember, if you expand cosine 5t and sine 5t, it's related to the exponential function, so you will end up having, in a way or another, the same results. Both of them are correct. That was the end of classwork 1, if you remember. For classwork 2, which you already had a couple of weeks ago, 2 weeks or 3 weeks ago, also it was covering the application of Laplace transform on ODEs. Then you had partial differential equations, numerical integration, numerical treatment of differential equations. Also, you had a double integral problem and a line integration application. He's giving you a mechanical problem which is in control, and then he gave you the main differential equation with the initial conditions. All I have to do is to find f of s for each one of these parts, and it's really very simple. If you like to have it, it's simple, direct, and you should solve it like this. First of all, I will start taking each part of these parts and get its solution. So you have y double dash of t, which if you try to get Laplace transform for this function, it's going to be s squared times f of s minus s times f dash, f0, then minus f dash at 0. This is for the second derivative. For the first derivative that exists, y dash, so Laplace for y dash of t, simply it's going to be s times f of s minus the value of f at 0, Laplace for y of t, and you will have to write it this way. It's going to be f of s On the right hand side you have cosine t, and the Laplace for cosine t simply gonna be s divided by s squared plus 1. All I have to do is to make the substitutions. This part is gonna be 0, that also 0, and this one is gonna be 0. Just make a quick substitution, and this way you will have s squared times f of s only. Then you will have 2 times s of f of s. Then you will have f of s, and all of this on the other side you will find s over s squared plus 1, trying to take f of s as a common and isolating f of s and all the rest of the variables on the other side. You will end up having s divided by s squared plus 2s plus 1 times s squared plus 1, which is simply can be put on the main form. You have 2 complex roots here, and you have, I believe, a repeated root of 1 for this part. Okay, so direct problem, no complicated steps. As I told you, here is s plus 1 to the power of 2. You have here, you have a repeated root of -1, and you have 2 complex roots. All you have to do is to apply the heaviside part, and you will end up having your results. This is for the complex part. You have only a, which is half. The b will equal to 0 once you start substituting. For the repeated part, you will have e to the power of -t. Then you will have to replace s plus 1 to the power of 2 and apply the part of heaviside for a repeated root. Also, I've said that more than once. If you have any problem, please try to resolve this part or to review it in depth. It's really, very important. We covered the application of double integration for a problem. For the first problem, how to graph your area, then how to identify which way to go, either to the x-axis first, then the y-axis, or vice versa. Also, you have an application